So I will start with a short presentation. So I'm Anova from the company LASEA. I'm project manager, and LASEA is a Belgian company that produces and manufactures micromachining high precision laser machine. And in the frame of the SYNTECS project, we have developed the laser machine, and we have integrated all the components from the partner to fulfill the requirements for the user. We start with a short presentation, and after that, we will have a live demo because we have here in the lab with my colleague Matt, and we will show you in live the machine. So just few slides about how we have done the job to create this machine. So once we want to create this kind of machine, we have to firstly ask all the requirements concerning the use case and take this in consideration when we will build and design the machine, and also all the interface that we will have with the components developed by the partner. So here you see all the structure of the laser machine. We have an enclosure all around the internal part of the machine, and we have few components in laser machine, this aspiration systems, and also all the control of the laser system. Inside the machine, we have on the back of the machine all the electrical parts, and on the front of the machine, all the parts for the processing part. So we have all the monitoring module, the delete module, and the axis that we will show you after. So inside the machine, we process by doing few CAD files at the beginning before to manufacture the laser machine. So here you can see all the mechanical axes that we put inside the machine. The size of the component that we can process is more or less the size of the implant. So it's a little bit more than 20 centimeters by 10 centimeters, like a 0 meter here. And we have inside the machine 5-axis systems with galvanometric scanner synchronization. So we expect 7-axis motion, 2 rotary axes, 3 linear axes, and 2 optical axes in the galvo scanner. So we have also integrated and used TMC software to process the 3D cards. So here's a picture how we do it on the cut of the implant. So we have a 3D capability by synchronizing the axis, the 5-axis with the 2 galvano scanner axes, and we produce little tiles to process each tiles by them. So we have also inside this software all the machine simulated of the screen. We have also possibility to position in 3D thanks to camera or touch fork. And at the end, with this software, we can control all the machines, so we can start the laser and visual. So here's just 2 videos to show you that on the software, we can see the motion of the part and the little size that we process, and at the same time, we process on the laser machine. So we will show you another application during the live demo. So as we present, we can do a lot of different textures thanks to this laser machine on different materials. So I will just show you the 2 applications that we create with this machine and 2 videos. The first one is the intent application. The first step was to test on the semi-spherical component, as you can see here, and we have processed black marking all around this surface by keeping intact all the textures. We have also processed the stem and the cusp, as you can see here. So we had 3 different kinds of texture on this stem, and also we have done a QR code with the print-based logo by doing black mark. So depending on the shape, we have to do type of file that we upload inside the software, and after that we can process it, as you can see. So here is just an example of what we have done with the QR code because it's a specific mapping. And we can see that we use some first implement on GetSpace where we can position very accurately the different spots. With this machine, we are able also to change the pitch of the building and also to work with a spot size of 60 microns if you want to use a direct reader. For the mode application, as already presented by Andrzej, we have put the mode inside the machine here. We have processed, as you can see here on the view, firstly, one microsector on the node. We have sorted after that the node, and after we have applied nanotexture on the node. As you can see here, we see this nanotexture thanks to the rainbow effect. First, we show conclusion. So it's the first time for our knowledge that a simple that delete module was combined with the 3D laser machine, and we do it with the SYNTECS project. With this kind of machine, we have high flexibility because we can change easily the pitch, and also we can use spot size, spot size of the beam. We have a very accurate control thanks to the person level function of the laser, and we can do with black mask. So it's very well adapted for various applications. So now, with my colleague Matt, we will try to show you more precisely the laser machine in live. So we stop sharing here. Moment. I show you the laser machine.
Okay. Hello, everybody. So here is the SYNTECS machine, and we can open the door, sliding door, and inside of it we have 3D. We have a model of it of them to make the presentation, and here I can start for a side of the machine. I just need to find my mouse. I make the shot compilation again. And so we'll add the SYNTECS logo with the QR code and extraction. And so the machining is starting.
Bobby, come, please. Fast. Run.
Okay. During the process, okay, so now it's working. Sorry, I forget to open the shutter of the laser. So now the process is starting. So as you can see, we apply a texturation that will change the black starting white. And so during the rest of the process, I will show you the rest of the machine. So I will show you the back side of the machine. So here we have the laser of the machine with the beam way, the optical beam way, and we go through beam expander. Here we use it as a beam reducer, and we arrive with a laser beam on the other side of the machine. So here we have two last mirrors to redirect the laser beam. We go through LS Polar. It's a module of LASEA to control the polarization of the beam. And we arrive inside the fusion bionic module to where we will be able to select Gaussian beam or a delete beam to have the delete pattern on our samples. Here we have the touch probe. That's it's a module that will be able to touch the samples to correct his position in the software. Here we have the acoustic module from the Fraunhofer. Here we have the spectrometer system and this light that you can see on the sample. You have the laser, but also actually the light of the spectrometer. We have an aspiration system and all the axes, an EDS camera, and thanks to the camera, sometimes we are able to correct also the position of the sample system. Can use the touch probe or the camera depending on the sample. And we have the FP panels. Okay. So now I will share the screen on the machine. Okay. So as you can see, at the same time that we have the production in the machine, I need to change my notes. Okay. So here we're able to check the machine and to change the view and to check everything's in the machine. So here for this site, we have two kinds of 3D texturation. The first one is 2D texturing. It's what we use right now. It's well adapted for big area. And the other one, we use it for more precise design. For example, the logo syntax of the QR code. So actually, all of this part and after we finish with the logo and the QR code. Inside this software, so we have two process. We are able to select the hatching. Hatching, the kind of hatching. So I can show you everything here due to the fact that we are running. But you are able to select some parameters for the hatching, also for the marking. So the laser parameters like the power, different laser delay, the mark speed and the jump speed. And of course, able to select it also for the QR code. And it's where we are selecting the POD to be able to have an exact positioning of each pulse on the machine. And it's why we are able to have to use really the full potential of the delete system. Okay. So inside the software, we have different parts. We also have a camera vision. So here, if you want, you can see the machine with this camera. We have some edit tools, so I can show you. And about the website itself. So it's actually it's a machine of class 1 for the safety, laser safety. Here we are working with an open brew, why we can the pass, but it's really a class 1 machine. back on the live process. So yes, here is the final stem produced with this machine, with different kind of texturation for this part and this part, and the black marking with the logo syntax and the QR code produced with this machine. So as you can see, every part of the stem is textured. I'll do some tests on over half sphere, doing black marking, different ones than the ones that we use on the stem, but it's still a black marking with logo syntax. And just finish the last parts. And now so the QR here it will not be a black marking due to the fact that we have to do a black marking on the black sample. Okay. So it's released. Shall remove it. Sorry, I have a problem with one hand, so it's all shoot. So thanks to this system, we're able to place the sample very precisely in the machine and to replace it. So okay. So it's finished a part of the presentation of the SYNTECS machine.